All right, welcome everyone today to Physics 11. The show today is going to be about vectors and scalars, as the sign says. So let's take a look and see what this all means. Going step by step here. Scalars are quantities that have only magnitude. Magnitude is a $10 word for size or amount. They are represented by numbers. Now, vectors are different because vectors are quantities that have both magnitude and something else. Magnitude and direction. So when you talk about the values that a vector has, you need to provide those two bits of information. Typically, vectors are represented by the number and the direction, but also there's a useful version that that represents vectors, and that is an arrow. Now, for some reason, my physics teacher didn't like that, but I don't know, seems reasonable to me. So, with what we're going to have to do is use them to represent different physical facts. So, as an example, let's say that you wanted to represent velocity. So this is for our example. And let's say you want to represent a velocity of 3 meters per second. Well, hopefully at this point you're saying, and what else? Because of a vector, which velocity is, requires two bits of information, the amount as well as the direction. So we'll say to the north. All right. Now, to show what this looks like as a vector, well, get this. You put your ruler down, you make a nice straight line, make it say 3 centimeters long, draw it to scale. It would be of some sort would be ideal. All right, so that this length now represents the number 3, and it represents the quantity 3 meters per second. To make it a vector, we have to give it the direction of north. So all we do is put the arrowhead on the top, and it shows which direction the vector is pointed in. And I think usually we agree that north is upward, so this vector is pointed in the correct direction. This vector is pointing in the direction of north. Now, what's going to happen is vectors can be used to represent different quantities, and these quantities are going to have to be combined in some way, added or subtracted, and maybe even the resultant, try and figure out what the combined effect is. So the first thing we'll do is take a look at adding these things. That is, adding vectors. And we're going to start by first adding numbers, just to show you how it remind you how they work with integers and such. And then we'll do it with vectors so that you can see it in action. All right, so with numbers, basic rules that you know but probably haven't thought about for a little while, and that is we can put the numbers in any order. As long as you drag the sign along, you can put them in any order. Now, each time we add a new number, what happens is, that is if you're making a chain and you're keeping track, each time you add a number is you start where the last one left off. You start where the last one oops, it's not one word. Where last one left us. Now the result, or the answer rather, and in brackets you can call it the result, is counted from start to finish, is one way of saying it, but with numbers you want to be going left to right. Oops. Left to right. Remember, the goal is to connect these numbers with vectors. So let's look at it like this, where we're going to be adding from start to finish. So they have a couple examples there. So I'll draw my own number line, put them on there, and you can see how these are related to, or start seeing how these are related to vectors. So let's look at the first expression they have. They got a 3, and then a -2, and then a 1. Let me put it on this number line here. 0 in the middle. So this is a +3, and what I'd like you to keep in mind is this this XY axis here, and it's nothing original about it. It's been around for a couple hundred years. But importantly, positive X is on the right, positive Y is up, negative X is on the left, and negative Y is down. So in a way, it's like a different language or a code. Whenever you have plus X, it means the right. If you have negative X, it means left. Positive Y, up, and negative Y, down. But anyways, let's get back to these numbers. We'll step up to this pretty soon. So we have +3. So that means we go to the right by 1, 2, 3. 1, 2, and 3. So there we are. Next, we go left by 2. So that means we go there and there, which puts us at the number, happens to put us at the number 1. And then we go 1 to the right, which lastly puts us here at the value of 2. So that now shows this chain of numbers and the resulting combination of these numbers. It's pretty good. Let's do the second one. I'll do it underneath, just so we have it all in one picture and we can compare. The second one is 1 plus a negative 2, and then a plus 3. So with this one, we start at the value of plus 1, and then we go 2 units to the left. So that's going to be here at, do it in red so it's a little easier to see, hopefully. Start at the 1, or what am I talking about? We start at 0, and then we go to the 1. So let's do it like that, properly. So 0 to 1 goes there, and then we go left by 2. Not 2, 2, but left by 2 from where we are. So that goes to back that way by 1. That's to the left by 1, and to the left by 2. So now we're at this location. Then lastly, we go to the right by 3. So squeezing it in, we get a right by 1, a right by 2, and a right by 3. Which puts us where? Happens to be at the same location. And so what we've done is we've shown that first of all, by keeping track of the direction, and then also always going left to right, we're allowed to put these numbers in different orders. So let's take a look now and see what happens with vectors. See how it compares. So with adding vectors, let's try and find some parallels. Building a metaphor, the connection. What does this say? First of all, we can use the same 3 rules it says for adding vectors. So that's nice. The structure is the same. So just like numbers then, we can put vectors in any order. Just like numbers, we can always add a new one. And continue on from where the last vector or vectors left us. So what we can do is start where the last one left us. Okay, the answer, again in brackets, that same word, resultant. As you can see, the word result is in there. Right, so the thing we get. Now for a vector, it goes from start to finish. Goes from start to finish. Because remember, it's a direction. So it's got to be a direction from somewhere. So where is it a direction from? From start to the finish. So, as you can see now, we have vectors there. Numbers plus directions. They're combined together. And so, let's find out what this combination is. What the resultant effect of these 1, 2, 3 vectors is. So the first thing is to show 5 meters per second to the right. So I'm going to start here, just because. And I don't know if you can see, I'm going to try and use a couple lines for each. 1, 2, 3, 4, 5. Okay, that's supposed to be straight. You guys can do way better than that. And it's to the right, so that means the arrow goes there. Next, we go up by 3 from here. So, trying to keep the same scale. 1, 2, 3. I'm now up there at up there by 3. This length representing meters per second. And then once we've gone all the way up, we're going to go down by 4. So I'm going to do it just off to the side, but it's really over on top of it. It doesn't move over, just so you can see it. So we're here. It goes down by 1 now, 2, 3, and now we're down here. And it's a vector, right? So we got to have the vector, the arrowhead there at the end. Yeah, this is pretty good. I guess we could improve it by 1, and you need to if we're going to get along. A ruler. And 2, you got to have some good looking labels on here as well. So here it's 5 meters per second. The arrow shows it's to the right. So you can just put a 5 meters per second there. The first arrow, that's 3 meters per second up, like that. And then the next one is 4 meters per second down, like that. Now, importantly, the resultant is from the start to the finish. All right, so where did we start? Well, we started way back over here. Start. Now, when you're starting out, don't be afraid of using some English and to help improve the communication of your diagram. Okay, later on, you can get fancy and call this S instead, or A or something like that. All right, so we started here, went there, down there. So this is where the finish is. And the resultant is the connection from the start to the finish. Now, in math class, I make people circle angles and stuff just so they don't lose track of where they are. Okay, so I'm going to show you the answer first, and then I'm going to show you what people do. It's like they panic under the pressure. Now, I don't have a ruler, but I got a straight edge, so that's what I'm going to use. That's going to look good, I hope. All right, I got a different color. Sometimes people use a dotted line. Dotted line's also good. I recommend it. Okay. So this is what people. This is the proper way, from the start to the finish. And what's the direction from the start? Oh, it's over here. We started there. We went that way. And so that's where the arrow goes. For some weird reason, people draw it that way across it for some reason, like the other cross direction. So, perhaps to begin with, label the start and label the finish with words and circles so that you end up with a proper, good-looking picture with the proper resultant drawn in place. All right. Now what we can do is we can clean it up a little bit. Because we can change the order around, we might be able to create a nicer picture where we don't have all of this going on. One vector on top of the other one. So if you're okay with changing the order around, then instead of doing it in the order that's given, let's just switch it up. So the given looks like, the question is like this. Well, you have it there. But just so, whoops, I want to have right written in there. Why? Because it's a vector and it needs direction too. So this is what the original one was. Up and then plus 4 meters per second down. Down. It's not very good. Move it over next time. So now what we're going to do, we'll switch the order so we don't have the up and down on top of one another. So I'm just going to put the up first. It's positive 3. Like it's plus, but it's actually positive 3 in there. It's invisible. Or the number is, but that shows it's positive 3, the up. So up like that, we put that first. Then we'll put it to the right. So we draw that vector next. And then we'll just have this one at the end. We'll keep it there. Meters per second. DOW. It's still a little tight there. Down. On that side. Okay, so to show this picture, we can almost match it up. Well, almost match it up with the numbers here. First of all, we have our start, which we will label. It goes 3 meters up, meters per second. Then it goes 5 to the right. And then because we are drawing this to scale, right, this should be like 3 centimeters or something like that. This is 5 centimeters or inches, whatever scale you have. And I point that out because here we're going down by 4. So we're actually going past this. So the picture should show that. And pass it by how much? By 1 meter per second. Okay, if you draw this to scale, then the picture does the work for you. You can lay the ruler down, as I will, and actually measure this out, and that will be the answer. So, this is true. What I've drawn here was let's get it looking good. We got a 3 meters per second for this section. It's a 3. We have this section going at 5 meters per second. And then we have this section as down by 4 meters per second. Already there. Where does the resultant go? Right. Not from S, but from start. And where does the resultant go? Right. Not to F, but to the finish. And putting a ruler down, making it look good. You get the dotted line going like this, with the arrow pointing at the end, at the finish. Okay, so that's the resultant vector there. So two different orders, because we can, as long as we watch the signs. Right? But we do get the same result. If this was drawn accurately into scale, you should be able to take this resultant and lay it on top of the other one. and they will match. Now, first quantity we're going to be looking at, which creates the basis of the physics we're going to be doing, is well, the quantity is that of length, I guess you'd say. So we have distance and displacement. So now we're starting to get technical. So for the first blank there, for distance, how far something goes. How far is it to the store? 10 meters. That's 10 kilometers. Right? So that's a number only. Because it's on the information is a number only with a Y and an L. Number only. That means it's a scalar. How tall are you? The direction is up. We get it, right? So how tall are you? 170. Right? Number only, scalar. But the displacement, because it has two bits of information, a number plus a direction, right? That's what a vector is. Okay, so displacement, and this word's going to come up a lot. We're going to, well, first of all, the two are going to be interchanged, perhaps a bit confusing. But later on, we'll be using displacement quite regularly. All right, so for the number only, this is what the distance is. For number and direction, this is the vector. So for the distance, importantly, okay, the path that you take, the path that you walk on, the path that the object slides on, that will give the distance. The change in position, start, finish. Okay, that's the key for a vector. In the case of displacement here that we're talking about. I mean other vectors as well. Now notice it's a bit like talking a bit like a caveman, but that's really just to get the idea down to a small group of words that are easy to remember. Right? Easy to associate. So distance, scalar, it's a path. Displacement, the vector, start, finish. All right. So hopefully with these bits of information, it is enough to get you started on the next part of the path towards the physics we are doing. All right, so just to take a look at what we did today. First of all, we described what vectors and scalars were. We built the model around the idea of what numbers are, and then made the association with vectors and how they are related, which is nice. Building an idea off something we know. We did a couple examples. Importantly, with adding. And I gave you the serious caution of showing the start and writing it down, and then showing the finish and writing it down. I said use a ruler and really didn't. You have to, I think, as you know, and draw clearly what the direction is. And then lastly, started giving some connection with the some terms that are going to come up in physics, namely distance and displacement. We'll say scalar vector. Distance, that's the scalar, so it comes first. And then displacement, it's not going to fit. Displacement. That comes second. All right, that is all for today. Hope you found it informative, and as a consequence, you find the future work you have to do enjoyable and informative. All right. See you next time.